Trump with Grain Journal Magazine in Decatur, Illinois. Welcome to today's webinar, Baghouse Filter Maintenance and Troubleshooting, presented by Kice Industries. Do you know how to size your filter to fit your needs? Today's webinar will touch upon the types of applications, function, and design considerations for your baghouse filters. Today's presentation will also address some of the troubleshooting symptoms, issues, and solutions for a typical application. This webinar is presented by Kice Industries. Our presenter today is Josh White. Josh is the sales manager for the West Central region of the U.S. for Kice Industries, where he has worked since 2000. During his time with Kice, he has held many positions including fabricator, welder, order planner, component sales, technical sales, and systems designer. He has spent the last couple of years in the role of supporting the Canadian, Mexican, and Caribbean markets for Kice Industries. In 2017, he took over the West Central U.S. region for Kice. He is actively involved in several internal committees and is a leader in process improvement, product development, and strategic planning teams. He enjoys opportunities to share what he has learned and experienced over the years and to help educate people regarding pneumatics and air process systems. Questions may be submitted to us today by typing them into the questions box at the right-hand side of your screen at any time during our webinar. We will be answering your questions during a live Q&A session following our presentation. At this point, Josh, can you please do a voice check?
Yes, I can. Good morning.
Good morning. We can hear you perfectly. Now, can you please show us your screen?
All right. Am I up and running?
Let's just give it one moment. Here we are. Are you in presenter mode yet?
Yes, I am.
Okay, you might, I think you'll need to switch screens to your, oh, there we are. Ladies and gentlemen,
there we go.
Here is Josh White.
All right. Thank you, Kendall. And good morning, everyone. Thanks again for logging on and spending a few minutes here. Hopefully we can share some good information and get some good ideas going and hopefully have a good back and forth at the end of this. I will start by saying that obviously I'm with Kice Industries, so most of the pictures you see, most of the information I have will be regarding Kice equipment, but the information that I'm going to try to share is fairly common across the industry. So if you have non-Kice systems, which I'm sure many people do out there, hopefully you can glean a lot of this information and use it within your existing systems. So just to jump right in, what is the use for a baghouse? Where do we find baghouses in our plants? First and foremost, baghouse systems are used in dust control. You will find a baghouse at the end of a dust control system. Dust or product is picked up from various points across your plant, whatever your process may be, pulled to a baghouse where it filters the particulate out of the air and discharges clean air into the atmosphere. Silo venting or bin venting is another common area where you will see baghouses. When we pneumatically convey material to a bin, especially pneumatically conveying, we have to exhaust that air somewhere. The air and the product that we're pumping into the bin has to release somewhere. Hence, the baghouse filter is a good option for that. It will capture the dust, keep that within the bin, but allow the clean air to exhaust the atmosphere. And of course, receiving. We can use a baghouse filter at the end of a receiving line, whether it's a positive pressure system or a negative pressure system. We can use a baghouse to capture the material and inject it into a process, whether it's gravity fed into a mixing bin or maybe injected through an airlock valve into a pneumatic conveying line to be carried off into the process. And also in negative pressure systems, you'll see these at the end of the central vac system as a receiver. So those are just a few of the common applications. I'm sure that you have other baghouses on different processes, but this is probably where you're most used to seeing these. So how does a baghouse work? A baghouse is a pretty simple animal. Dirty air that's heavy with dust and particles is drawn into the baghouse. The air is drawn across filtration media or SOx most commonly. The particles, the dust, the product is captured on the socks. The fabric filters the air, and clean air is discharged from the baghouse. Pretty simple process. And one thing that is most common in baghouses is a pulse jet cleaning system, which you can see on the animation here. The point of the pulse jet cleaning system is to help keep the bags clean and extend the life of the filters and extend the efficiency of the filters. Now, one thing I like to point out on this slide, if you notice the timing of these bags being fired down, you can see the blue column indicates which row of bags is being cleaned. Now, it doesn't go in order left to right, 1, 2, 3, 4, 5. You can see that it skips around, and it is almost a random pattern. And now that's on purpose. And the reason that we do that is so that when we clean row 1 of filter bags, we don't immediately go and pulse row 2, knocking the dust and the particulate back onto the clean bags of row 1, and then down the line and down the line. We like to stagger the pulsing inside of a baghouse so that that cleaned row of bags or that pulsed row of bags can have at least a little bit of time to operate as effectively and efficiently as possible and draw dirty air in order to clean it through it rather than knocking dust from the adjacent row onto the socks. So if you have a filter, on a Kice filter, you will see a timing sequence located in the timer board enclosure, and the numbers are never in order, and that's on purpose. So if you ever notice that or see that or notice that your blast valves are not firing necessarily in order, left to right or right to left, that's the reason why. That's just a point that I like to point out. So we know how a baghouse works. How do these filter socks work? Well, inherently, a baghouse is a very, very efficient air cleaner. Most common filter bags out there on the market are going to be 99% plus on most dust particles, say 15 micron, 10 micron, and larger is going to be a very, very efficient separation through these filter bags. So the most common filter bags that we use, and I believe is most common out in the world, is what is referred to as a surface filtration bag. The surface of the bag or the fabric of the bag actually captures and holds this dust and builds a surface layer, or what we call a dust cake, on the filter bag. And that is what adds to the effective filtration. We're actually using the fabric itself along with a small layer of dust that's embedded itself into that top layer of fabric to filter and to clean the air as it passes through the bags and exits through the suction fan. So with that being said, it's difficult a lot of times to just open up the access door in a baghouse and use your eyes to see how dirty a set of bags are. A lot of our processes, the dust may be light colored anyway, so it's hard to gauge how dirty they are. But if you take your finger and flick a bag and you get a little bit of dust that comes off of it, that may not necessarily mean that's a dirty or plugged bag. We actually want at least a small amount of dust cake or surface buildup in order to effectively filter that air. And then again, this slide references the reverse air cleaning. We talked about that a minute ago. We have an air tank reservoir that contains pressurized air, and it feeds blast valves on a timing sequence in order to clean out one row of bags or one set of bags at a time. So now I'm going to touch on some of the common baghouse cleaning systems, talking about pulsing. And again, what you're going to see and what I'm going to refer to as Kice lingo, Kice products, but again, there are many other filters out there, other companies that manufacture these same types of filters, and it's fairly common technology across the industry. The first one we'll touch on, we call our high pressure, low volume cleaning system. We refer to this as our Venturi jet style filter. And this uses house air or plant air that you already have available. You can see that there's a small air tank there above the access door. That's where your plant air would be stored. We like to clean these bags down at 80 to 100 psi, and it's a very low volume of air. So high pressure air at a very low volume. That high pressure, when it's pulsed or when it's shot down into those bags, actually gives a really good pop, a really good whack to those bags to help knock the dust off, to help keep them clean and extend the lives. The next style would be our medium pressure, medium volume cleaning system. You can see on this one that air tank that's located on the left of the picture there is actually much larger than the air tank on the last one. That's because we're going to clean with a much higher volume of air, but it's also at a much lower pressure. This baghouse will typically be fed by a dedicated air power unit or a blower package that's going to provide the air for cleaning. So we'll have a blower package hooked to that air tank. We're going to let that air tank build pressure to about 10 to 12 psi, and then our timer board is going to tell each blast valve one at a time when to fire down. So we're actually using a lower pressure of air, but a larger volume to actually rush or help flood the dust off of those cleaning socks. Same goal and largely the same effect as that high pressure pop, just a little bit different way of cleaning those bags. And another style that's pretty common across the industry, we call this our CR filter. This would be a low pressure, high volume cleaning. This picture on the lower left is a cutaway of what's going on inside that filter at the very top. This type of filter actually has a dedicated fan, a dedicated blower fan, connected to a rotating arm. And this arm is on a sled that actually seals off a couple of rows of bags at a time, and as it rotates around continuously, blows down each row of bags as it makes its way around. Now, this is at much lower pressure than the past two types that we had talked about, but a much higher volume of air. And that continual downward pressure, that downward rush of air, is what helps us keep the bags clean, knock the dust off, have it taken away by the airlock at the bottom, and help extend our bag life. Now, on the pulse jet style, the Venturi jet and our new jet, or our high pressure and medium pressure filters, those are a pulse type cleaning system. The CR filter is a continual cleaning system. But on the pulse type cleaning systems, you will see this type of gauge cluster. And again, this is a Kice setup, but you'll see something very similar to this on just about any baghouse out there. On the top, the small gauge you see is our pressure gauge. That's hooked to your air tank and allows you to read the pressure inside of your air tank. For the high pressure, low volume cleaning system, we know we want 80 to 100 psi. This pressure gauge will allow us to take a reading in that air tank at any time and make sure that we are building the pressure that we want, and also make sure that we're not over pressurizing as well. The larger gauge on that upper picture is called a magnehelic gauge. That shows us the pressure drop, or the resistance that the bags are giving to the fan across the baghouse. The dirtier your bags are, the higher the magnehelic gauge will read. We'll touch on that again here in a few minutes, but that is the good telltale sign of when bags are becoming dirty and when a filter bag change may be needed soon. And of course, we have our timer board, our electronic timer board. We'll touch on this again a little bit more in a few minutes, but that allows us to adjust the firing sequence. It allows us to adjust the time between firings and allow pressure to build up in the tank, a very important part of the baghouse system. And again, we'll touch on each one of these briefly in a few minutes. So let's talk about design considerations. What do we think about as an equipment manufacturer, as a system designer? What do we think about from a sizing and engineering standpoint to size a baghouse for you? We don't just have a small, medium, and large baghouse and decide which one fits the best. We take a lot of things into consideration. The most common, the most visible, and the easiest to speak about are air-to-cloth ratio, the velocity of the air and the particulate inside of the baghouse, and then, of course, what I just mentioned, pressure drop across the filter. We're going to touch on each one of these for just a minute, but again, these are just a few of the things that we like to think about when sizing a baghouse for you. So hopefully this can maybe help you back into the equipment that you have and make sure that you're comfortable things are sized properly, especially if things have changed over time within the process. So first thing we'll touch on is air-to-cloth ratio. What does that mean? Air-to-cloth ratio refers to the volume of air that we have to clean, how much air are we putting into this baghouse, and how much filtration area do we have to clean that air. So simply stated, it's volume of air, CFM, versus square feet of filtration area. If I take a filter bag out of this baghouse, I cut a slit down one side and I lay it flat on the ground, I can measure the flat surface of that bag. I can measure how many square feet of filtration area we have. That's how we find out how much filtration area in the entire filter. So I have an example written down here. We've done some calculations, we've done our homework and our background work, and we've decided that your dust collection system is going to require 8,000 CFM of air. So we know that. That's a given. That's another process we've already completed. So I've worked here quite a while. I think a VR96 is probably pretty close to the right size I'd want to use on 8,000 CFM. So I'm going to start doing my math. I know that a VR9610, which again is a Kice part number and a Kice specific nomenclature, but what that tells me is that this filter that I'm going to look at has 96 filter bags inside, and they're 10 feet long. So my 96 bag, 10-foot long bag filter has 1,131 square feet of filtration area. That's a hard and fast number. We know that. You can call Kice any day of the week, and we're happy to give you that information on any filter of ours you may have. So I've done my homework. I know I need 8,000 CFM. I think my VR96 is the right filter. 8,000 CFM divided by 1,131 square feet gives me a 7.07 air to cloth ratio. So I have 7.07 CFM of air per square foot of filter media. I like that number. I think that's a pretty good number. Now, why do I like that number? How can you tell if that's a good number? Here's some rules of thumb that you can think about. Again, these are not hard and fast rules. These numbers can probably be argued between manufacturers. These numbers are definitely dependent upon the application that you are in. But in just a roundabout way and as a rule of thumb scenario, these are numbers that you can typically fall back on and use as a guide. In rougher cleaning, elevators, cleaning houses, really dusty, heavy-duty applications, a higher air-to-cloth ratio sometimes is okay. 7 to 10 to 1. 10 to 1 is a little high for me. 7 to 1, 8 to 1, not a big deal. And you can see as the critical aspect of the filter gets more important, secondary collector after a cyclone, or a filter receiver, which is the main receiver on a pneumatic line, our air-to-cloth ratio goes down. The lower the air-to-cloth ratio, the more efficient your baghouse is going to be, the more effective it's going to be, the longer the bags are going to last. But you want to be careful that you don't get crazy and try to have somebody size your baghouse at a 1-to-1 air-to-cloth or a 2-to-1 air-to-cloth. That's really too much filter. That's more filter than you really need. A 7-to-1, an 8-to-1, somewhere in that range is typically a good application number for a baghouse. And again, your product, your application, your process may dictate that a higher air-to-cloth is okay, or we may need to think about a much lower air-to-cloth ratio. And I will mention, this is the only time I'll mention in this presentation, but pleated filter bags are common for some folks, not standard for us. But if you do use pleated filter bags, if you do use pleated filter cartridges, a lot of people call them, those have to be applied at a much lower air-to-cloth to be effective and to have any kind of a good life expectancy. So if you are working with pleated cartridges, these numbers that you see here, you can effectively cut those in half or even much, much more to be able to gauge on where you are with your filter system. So the next thing that we think about, we've got our air-to-cloth ratio. We think our VR96 filter is okay. We're going to think about interstitial velocity. What does interstitial velocity mean? Interstitial velocity refers to the upward movement, the speed that the air and the dust and the particle and the product in the baghouse is moving between the filter bags. How disruptive is this air? How fast is this moving? How much is this product being flown around? Well, we know, and again, that these are numbers for Kice, and these are numbers that we're happy to share with anybody, but we know, since we are looking at our VR96 filter, that we have 43.43 square feet of open area between the bags inside of this baghouse filter. That's our open area. We're going to divide our air volume by the open area we have available inside this baghouse to find our interstitial velocity. So again, our 8,000 CFM divided by my 43 square feet of open area gives me 184.2 feet per minute interstitial velocity. I like that number. I think our VR96-10 is probably the right filter for this application. Again, why do I like that number? Here's another rule of thumb page. Again, not hard and fast numbers, just a good guideline to know where you stand on what we would recommend. Most dusts are going to be in the 25 to 30 pounds per cubic foot bulk density. So we like to say when we size filters, if we're below a 300 feet per minute interstitial velocity, we're probably okay. And like I mentioned earlier, there are a lot of other considerations to go into filter design. But if I had done my math and I came up with 400, I probably would have started to rethink my VR96. But we came up with 184, I believe it was. So we're in a really good spot. We're low feet per minute, low velocity. But why is that important? Why do we see that velocity number decrease as the bulk density of the product decreases? What we're measuring with interstitial velocity is the upward momentum, the upward movement of the air and the particles inside of the baghouse. If we are conveying sand, sand has a very high bulk density, and we can throw that sand around at a very high velocity inside the baghouse, and it's going to settle out of the airstream. It's going to fall down into the hopper through our airlock and be taken away. But if we are conveying granulated plastic, or let's take it to the extreme, let's say that we're conveying feathers, something that's as light as you can imagine, feathers to the baghouse. A feather is not going to settle out of an airstream very effectively. So the lower that velocity is, the more we can slow that air down, the better chance we have of our product settling out of the airstream. Again, a little bit later we'll touch on interstitial velocity issues, how you can find out if that's what you've got going on, what some of the signs are. But again, a very important consideration when sizing and designing a baghouse. And the last thing we'll talk about for design is pressure drop. What does pressure drop mean? As bags get dirty, it is harder for the fan to pull air through those bags. So when we design a baghouse system, we're not only sizing up the baghouse, but we're also designing the fan to pull the air, and perhaps we're designing the duct manifold and however much else might be involved in this system. So when we design an air system for dust collection, we think about pressure drop across the filter. We say, Kice says, that when your Magna-Hela gauge, your pressure differential gauge, reaches a number of 6 inches of water column is typically how those gauges are set up, it's time for a filter change. Now that's not just a number we made up, and again, other manufacturers may use different numbers. But why do we say 6? Well, we know certain types of equipment, if we're pulling through hammer mills, or if we're pulling through sifters, or if we're pulling through a cyclone collector, we know and we have record of different pressure drops, different amounts of air resistance you can count on from different pieces of equipment. Now, when you have a brand new baghouse with brand new bags that have never been run, the effective pressure resistance or pressure drop across a baghouse is going to be 0. You're not going to have any resistance. Your bags are going to be clean. There's not going to be anything stopping the air. But as that system is in use, and as that baghouse sees product, and as these filter bags begin to become dirty, that pressure drop or the resistance is going to increase. So we design our fans to overcome 6 inches of water column within that baghouse. So when your baghouse reaches 6 inches of water column, the baghouse isn't going to stop working, but what's going to happen is that fan is going to start diminishing in effectiveness. It's not going to have quite enough pull, quite enough guts to reach out and pull hard through those dirty filter bags. So you're going to start to see a negative effect in your dust collection system. Your pickup points might start to dust out. If you're by chance conveying to the baghouse, you might start to have troubles getting the product all the way to the filter. So that's why that pressure drop is important, not only for the baghouse, but also for the air mover as well. And again, I'll touch on that a little bit later, and I'd be happy to answer any questions on that later on if you have that. Explosion venting, I'm not going to talk about this for very long. This could be another topic for another day and another hour or longer. Explosion venting and explosion protection is becoming more and more important, becoming more and more common. There are lots of things we take into account. KST values, Pmax values of the product and the dust that we're handling. That's what's going to dictate how many vents or how much venting area is required on your filter. There are other pieces of equipment available to put in tandem with baghouses, backdraft dampers, chemical suppression systems, chemical isolation systems. That is not something that necessarily affects the operation of a baghouse, but it's something that it's important for you as a user to think about and be aware of. And any manufacturer that you talk to, anybody that you contact to help you with a new baghouse especially, or with a new system, should be asking about your explosion protection requirements. So just be aware of that. That's a conversation that myself, anybody here, or hopefully any other manufacturer will be able to have with you and be able to help you navigate on whether or not you need protection and what kind of protection and how much protection is right for you. So again, not going to talk about that too much. So let's go to some troubleshooting issues. We'll talk about some ins and outs of these baghouses, talk about some common problems, some common fixes. We'll kind of blow through these, won't spend too much time on them. Some of the common issues that we see, we'll touch on each one of these separately. Stack emissions. You see dust blowing out from your fan discharge. High pressure drop. Your magnehelix gauge climbs faster than you think it should, or it climbs immediately and stays there. Bag blinding, premature bag failure, moisture within the baghouse, and then of course plugging or bridging in your hopper at the discharge of a baghouse. These are all problems that as baghouse users would probably all seen and experienced and had to deal with one way or another. So stack emissions. Why would you see stack emissions? If you walk out behind the building tomorrow and you see dust and product flying all over the place out of your fan discharge, you've probably got a broken filter bag. Bags will tear over time. Bags will get worn out over time. But also bag installation. I don't know how many times I've taken phone calls from people that say, you know, we've installed a new set of filter bags on Monday, and here it is Friday, we're shooting dust all over the parking lot. What's the deal? Well, bag installation is just as important as anything else, and a lot of times it's the simple, easy things that are the right answer. So bag installation, we want to make sure we know what we're doing and we're doing it correctly. And then if broken bags are an issue and you do see that it's in a specific spot of the filter, or you do see that it's a specific pattern within the filter, maybe we need to talk about ways we can protect the bags against wear from material handling inlets. Bag shields are available for some filters. That's something that we can do. And then too frequent pulse cleaning. That's also something that can lead to premature bag failure. And we'll talk about that again shortly in another slide. So we'll talk about filter bag installation for just a second. I like to encourage people that when they change a filter bag, please change all of the bags at the same time. It doesn't do you a whole lot of good if you've got a set of bags that's been in the filter, even if it's a relatively short amount of time, 8 or 10 months, and one bag is torn or two bags are torn. Yes, it's quick, and yes, it's easy to go in and find those two bags and replace them, but you're not doing a whole lot for that baghouse. For my money, for my time, if I'm going to get inside of that thing and if I'm going to get dirty, you just as well pull out all those socks, do a sock replacement, and take your filter back to new. I just think that's a much better, more efficient use of time. You're not doing yourself a whole lot of favors by just replacing one or two bags. Again, time allows for what it allows for, and sometimes that's all that we're able to do, and that's fine. You're not hurting anything, but maybe not giving yourself the biggest benefit that you can. There are special bags available. We talked about abrasion a minute ago. High temperatures sometimes require special filter bags. High moisture applications, corrosive gas applications, chemicals. Some of these may require special bags. So if this is the type of process that you were involved in, if it's not just your everyday run-of-the-mill dust, make sure to talk to your filter bag manufacturer about that. Make sure that they're aware of that so they can work to get you the proper bags for your application. And something I'll touch on, I think, one or two more times before we're done, is periodic cleaning of the bags offline. Now, what I mean by that is, in a nutshell, I would like to see you turn the suction fan off on the baghouse, but leave your cleaning mechanism running for 5 minutes, 10 minutes. Take the air away from the baghouse so that you're not pulling more air, you're not pulling more dust to the baghouse, but give that cleaning mechanism time to run a few cycles, knock the dust off of those bags, and get those bags cleaned off. And what that'll do is at the end of the day, you let that cleaning mechanism run for a while. Tomorrow when you start up, you're going to have a good, nice set of clean bags. It's going to hopefully give you a lot more bag life and functionality out of that filter. Now, about the second most important thing when talking about that is to leave your discharge airlock running when you're running the cleaning mechanism offline. If we're knocking the dust off of those socks down into the hopper, we don't want to just let that dust sit there overnight or over the weekend and create a plug or create a bridge. We want to keep that airlock running. So let's say we turn our suction fan off. We set our timer so our cleaning mechanism runs for 10 minutes after the fan's off, and we set our airlock so that it runs 5 minutes after the cleaning mechanism is shut off, just to make sure that we get all that product out of there. Cleaning the bags offline will help keep your keep your filter bags cleaner longer, and keeping that airlock running is going to take that dust away from the filter to help prevent any problems. Filter bag installation, again, we've got details all over our equipment. We have pictures in the manuals. A lot of times people don't adhere to these, or people are in a hurry and these don't get installed correctly. We like to suggest that when you install a filter sock, the top of that filter sock is actually going to fold over to the inside of the filter cage before you slide it up onto the tube collar. That's going to help get you a lot better seal. It's also going to help that filter cage stay up on that collar a little bit better as well. So again, proper filter installation is important. Here are a couple photos of things we've probably all seen. On the left, that filter cage isn't even pushed up over the bead on that collar. So it's not but a matter of time until that filter cage falls off. Most most baghouses have an airlock on the bottom of the hopper, and I think we can all imagine what's going to happen when that wire filter cage falls into that airlock. Not good. Replacing an airlock valve because of a poor filter cage installation can be a pretty expensive endeavor. So proper installation is important. And on the right, we see that those bags weren't tucked in at the top. They're just raw edges. Not as bad of an installation as on the left, but you're not going to get as good of a seal or as good as a filtration as you could with those filter bags. There are top bag filters, top load filter bags. Those are becoming more common for various reasons. These are pretty simple to install. They typically have a spring-loaded top. You lower them down from the top of the tube cage. That spring-loaded top springs to form, holds itself in place. Filter cage slides down inside and holds the filter down. So just another style that you may have or that you may see out there. So let's say that we're experiencing high pressure drop, or your bags are blending over much more quickly than you think they should. You put a new set of bags in, and within 4 weeks you're already up to that 5 or that 6 inches that we say we recommend changing bags at. Why is that? Well, it's quite possible your filter is undersized. As we all now know, air to cloth ratio is a very important part of sizing a baghouse filter. If it was a poor design to begin with, if this filter was purchased 25 years ago for one application and has been reallocated to another application, perhaps it's undersized for that process. Over time, we modify the systems we have. That's just a fact of life. We modify our systems to get them to a point that we need to operate, and sometimes that includes adding more air or bringing more air or more dust, a higher concentration of dust, into a dust collection line. So ask yourself, what has changed? Has anything changed that's going to help contribute to that shorter bag life or that higher pressure drop, that higher, faster pressure drop? And then we talk about the cleaning mechanism, the air timer, the cleaning sequence, and the blast valves. Perhaps our bags are blinding over, getting dirty more quickly because we're not getting a good, effective clean on the filter bags. Well, how do we address that? Well, earlier we looked at the gauge cluster that we have on our baghouse filters. There's a pressure gauge. We can push that little black thumb button and read the pressure in our air tank. And we know on our high pressure cleaning system, again, 80 to 100 psi is what we're after. If you look at that gauge and it's never climbing above 20 or 25 psi, perhaps we have a leak somewhere, we're not able to build pressure. So we'll touch on that, but the first thing we can do is look at the timing sequence. Maybe the timing sequence has been off. Maybe your timer board fried out and you replaced it yesterday, and all of a sudden now you don't get the cleaning that you think you need. The two most important buttons or knobs on this timer board here are the very top blue buttons. There's an off time knob and an on time knob. And what those are going to control is how much time between firings, how much time are those solenoids off to allow the filter air tank build pressure, and the on time is how long are those solenoids on, how much time do you get the air to blow out of the tank and into the baghouse. So again, by using our pressure gauge, we can hold that button and we can watch that pressure build. We can watch that pressure build from 20 to 30 to 40, and then it gets up to 85 or 90, and then you hear the pulse, and the pressure dives down. We know that we've effectively pulsed 90 psi of air into our baghouse. Pressure's good. If we're seeing that we're only giving it enough time to build up to 60, maybe 70 psi, we can adjust our off time, how much time between firings. We can adjust that to a longer amount of time, which gives that air tank longer to build pressure. That's the importance of the off time. On time, we want to make sure that it's more than just a split second that those are open. It's measured in microseconds, so it's a very quick pulse, but you want to make sure that you're getting as much air from the air tank into the baghouse that you can in order to get effective cleaning and good regular cleaning. So those are all things that can be changed. We test those here in our shop. We do have settings that we put them at. However, everybody's plant air system or everybody's real world scenario is a little bit different. So it's always good to double check that during installation, make sure the timing seems correct for what you have. And if not, it's easily changeable, or give us a call. We can walk you through it and make sure that you're comfortable doing what needs to be done there. Well, let's say that we do check our pressure and we're not building pressure in our air tank. Chances are you probably have an air leak going by your blast valve. If the air tank is not holding pressure, that air has to go somewhere, and the only place that that air can go is through that blast valve and into the baghouse. So looking at our high pressure, low volume type of system, again, this is a Kice filter, but many manufacturers out there have the same type of blast valve setup. It should look familiar to you even if you don't have a Kice filter. Well, this is what the inside of that blast valve looks like. So what are the things that can fail? More often than not, that rubber diaphragm. We have a rubber seal that's inside there that creates a seal and a pressure differential within the valve that allows that blast valve to hold air pressure until the solenoid is told to release that air. There's a little compression spring in there that can break over time. And of course the solenoid, although not as common, the solenoid can burn up or give out over time and need to be replaced. So if you're not building up air tank pressure, first things first, take the top off of that blast valve, make sure everything inside looks good. Now on the other style of pulse cleaning that we talked about, our lower pressure, higher volume cleaning, much the same. What the inside of the valve looks like is this. Same type of scenario. This is a little bit larger, so we have a large diaphragm. That's about 8 inches in diameter. We have a larger compression spring there in the center. That over time can weaken, or that can break over time and may need to be replaced. And then the solenoid setup, our little square diaphragm with our little plunger, looks almost exactly the same as on the previous slide, the other type of cleaning mechanism. So the easy way to find out why you're not holding pressure in your air tank is to look at your blast valves. Now that's, I know, a lot of times easier said than done. If you have 3 or 4 blast valves, it's usually a fairly quick job to find out which one it is. If you have a larger filter with a dozen or more, 15, 18, 20 blast valves, that becomes a little bit bigger of an issue. There are things you can do to help you find this without taking apart every single one. If your installation is in an area where it's not in the direct sun or it's not in the outside wind, a lot of times people can take a temperature gun and shoot the bottom of these blast valves. If there is a leak in one of these blast valves and the air is doing nothing but flowing through, it's going to be a few degrees warmer than the one next to it, just because of the air movement, just because of the blower air that's moving through it. Sometimes you can feel it with your hand. Sometimes a heat gun's a good way to go. Now, on the bottom left here, you can see a blue arrow. There's a relief port underneath that solenoid valve there. When that solenoid pops and it allows air to flow through, what happens is that pressurized air on the top side of that big diaphragm is actually released. The air on the top side is holding a pressure equilibrium inside. When that air is released, that allows the diaphragm to lift up. Air from the tank goes to the baghouse, from the air tank into the baghouse, and cleans the bags. So you should be able to feel a puff of air come out of that relief hole. Sometimes when you're not able to build pressure in your air tank, if you go through and just put your thumb over that, you may be able to feel air leaking out, or once you put your thumb over a valve that's leaking, you may immediately start to see that the air tank begins to build pressure again. So not the way to find which one's bad, and not always the right way or easiest way, but again, just another idea to think about and something to help you pinpoint where your problem may be. So what are some other issues? Condensation is a big issue. I don't think anybody is surprised to learn that when dust gets wet, it becomes a mess. Depending on what kind of dust you're working with, it can be more of a mess than other types of dust. With our high pressure cleaning system, our Venturi jet style filter, where we use plant air, it is not uncommon for us to get phone calls wondering why filter bags turn out looking like they show here on this slide. You must have a good air dryer system on your plant air and a good filter prior to, a good airline filter prior to the baghouse to make sure you're using clean, dry air to clean those socks. If you're not, all you're going to do is shoot condensation and shoot moisture down inside of these filter bags, and in short order, you're going to have a gummed up, plugged up filter that's not going to do anybody much of any good. So again, sometimes the easiest, simplest things are the right answer. Make sure you have a good air dryer on your airline. Now, sometimes it has nothing to do with the air dryer. The second point here is talking about insulation. Maybe your filter sits out behind the building and you've got a nice process going on inside the building, but 2 months out of the year, when it's cold in your area, and you bring that warm process air out through the wall and into that cold baghouse outside, that can sometimes create condensation, can create moisture inside the baghouse, and that can lead to problems. So again, especially during installation or during a project bid process, think about that. Think about where this is going to be located. Think about the highs and the lows as far as temperature goes. Will that affect how this functions? Will that affect the material within the baghouse? Product bridging above the hopper is one that we talked about. And I can't stress enough, when it comes to a baghouse system, don't forget about the airlock. 9 times out of 10, we have a simple problem with the baghouse. Somebody calls, asks, why is my baghouse acting the way this is? And it always comes back down to the airlock. And people like to fight against that. No, I don't have an airlock problem, I have a baghouse problem. Well, the two go hand in hand, and if you have a problem with one, it can create problems in the other. Well, why is a worn airlock a problem? Well, an airlock valve does exactly what it sounds like. It is an airlock or an air seal between what's going on inside the baghouse, negative pressure, dust and material flying all over the place, and what's going on outside of the baghouse. Ambient pressure, maybe we're dropping into a trash bin. So what that airlock is doing is segregating the atmosphere on the top and the bottom of the airlock valve. Now over time, product will wear those airlock tips. They'll open up a little bit, and you'll actually be able to draw air into the baghouse through the airlock valve. And what that's doing is stealing air. First of all, stealing air from the downhill process. You might lose pickup at your dust pickup points, but it's actually percolating that material above the airlock. It's not allowing the material to settle down into the airlock and discharge, and over time can create a bridge, can create a bind, and you might end up with something like this. This is not a good surprise if you pop the lid off of your hopper, the access door off of your hopper, and Typically, they're not labeled clog like this picture is, but it's usually pretty easy to pinpoint what the problem here is. So allowed to go on long enough, you can create yourself a problem just like this, just by allowing that airlock valve to wear and create leakage and allow product to build up over the top of that airlock. Another point to make, going back a few slides, we talked about cleaning the bags offline, cleaning the bags after the suction fan is turned off. I made a point to allow that airlock to run as you are cleaning the bags. Probably not to nearly as large of an extent as this picture shows, but you can do this same damage by shutting off the airlock, but continuing to run the cleaning mechanism and allowing dust and product to build up over the airlock. Shouldn't be this severe of a problem, but I think you can use this to picture what would happen if you do that. So again, don't forget about the airlock. It is just an important part of the baghouse system. It's the baghouse and the fan and the ductwork. So that kind of brings me to an end. I just like to leave with a couple of points. Whether an air system, whether it's a filtration system, whatever it is in your process, understand the equipment. Do your part to understand what you're working with, understand the process, understand how everything works in tandem with other pieces in the process, and know how it works when it works well, and know how it behaves when it's not working well. Know what to look for. If you are confused about what you see, if you don't know how to fix a problem you're coming across, don't hesitate to reach out to the manufacturer. Don't hesitate to make a call to somebody. Questions are always free, and hopefully a quick, easy phone call can save you a lot of time and headache. And regular maintenance, routine maintenance, preventative maintenance, I'm a big fan. A little bit of work and a little bit of cost now can save a whole lot of cost and a whole lot of downtime and a whole lot of headache down the road. And last but not least, I always like to remind people, please work smart, be safe, and look out for those around you as well. So with that, I think Kendall may come on to address any issues or ideas or questions you may have, and I would be happy to address any there may be.
Thank you so much for a great presentation, Josh. We will now begin our Q&A session. If you have not yet submitted your questions, please do so now. Okay, Josh, our first question today. What are the results of having an air-to-cloth ratio that is either too low or too high?
So air-to-cloth that is too high, we're effectively flooding the filter bags with too much air, too much dust. A high air-to-cloth ratio is going to lead to your filter bags blinding over, or your filter bags clogging up, if you will, and not allowing for good filtration. And as we spoke, what happens with the fan when the filters get too dirty is the fan can no longer overcome that dirty filter bag, and it can't provide enough air to create good suction and good dust control. So too high of an air-to-cloth is going to lead to short bag life and very frequent bag changes. Too low of an air-to-cloth, I would love to be able to convince everybody that a 1-to-1 air-to-cloth ratio is the perfect filter to buy every time. Now, if you buy that filter, you probably will never have to change the filters, but you're going to have a big, big filter for maybe a small process. So the danger in a low air-to-cloth isn't necessarily with function. It's just that you've probably bought more filter than you need. You've probably oversized the filtration system compared to the process, and you really don't need that much air. You don't need that much cleaning. Now, if you intend to grow in the future, maybe a low air-to-cloth with the intention of increasing later is a good idea. But again, I don't think you should necessarily buy up now and pay for much more than you need.
Okay, our next question. Can you use your compressed air system on a filter that requires a separate blower?
No. The short answer is no. So the reason there is the intention of that style of filter, what we call our high volume cleaning mechanism, a typical air compressor isn't going to be able to provide the volume of air in any good amount of time to be able to clean those filter bags. Now, you'll be able to create enough pressure, but we're not going to be able to fill that larger air tank up enough in a good amount of time to get an effective cleaning on there. So that question comes up a lot, and there are people that have finagled ways to make it kind of work, But in a nutshell, no, it is not a good or effective idea to use plant air or house air to feed a high volume cleaning system.
Our next question, what would you estimate the extended bag life is when cleaning the bags during shutdown?
That's a good question. It's a very good question. It's a tricky question, just like anything. How long is it going to last? It depends on the process. It depends on the product. It depends on all kinds of things. I would like to think that a properly sized bag house on a normal application, you shouldn't have to change bags more than once a year. There are several systems that we have out there where bag changes are done, but every few years, 2 to 3 to 4 years. So if we can take a step back and say, I change my filter bags once a year now, what happens if I change my process and clean the bags offline during shutdown? I wouldn't have any doubt that you may increase that 12-month filter bag to, 15 or 18 months just by using that added cleaning cycle. Again, it depends on a lot of different things, but you will see a life increase on those filter bags by cleaning offline.
Our next question, what is the typical knocking time between firing?
Usually, I'm going to say 20 seconds, give or take. I think I might have been caught here. I believe our timer boards go from 0 to 30 seconds on the off time, and we're typically just a little north of 20 seconds. 20, 22 seconds is common. It's easy to know when you're giving it too much time or giving it more time to build pressure than it needs. Each air tank on our filters is equipped with a pressure relief valve. On the high pressure cleaning systems, the pressure relief valves are set at 125 psi. On the medium pressure systems that are fed by a blower, the air tanks are set at 15 psi. So if you have a bag house and you can hear the blower ramping up, or you can hear the airline filling up the tank, and then you hear a hissing sound, you hear that pressure relief valve go off, you know you've waited too long. You can dial down your off time to allow that to fire. Our relief valve set at 125 psi would like to blow off around 100, so you can turn that off time down quite a bit to bring the firings more frequent. But again, to answer the question, typically 20-22 seconds is about where you'll see a timer board set for time between firings.
Okay, next, how does cloth type, such as 12 ounce, 14 ounce, or 16 ounce, and air to cloth ratio work together?
That's another good question. 12 ounce, 16 ounce, 14 ounce, that is going to speak more to filtration efficiency. It doesn't necessarily affect the air to cloth ratio. It doesn't affect our calculations as to how we size a filter. What it does affect is how effectively or how well that particular filter media is going to capture and contain and release when the pulse cleaning comes on, how well it's going to handle your dust or your product. There are a lot of filter bag makers out there and a lot of different technologies, and there are arguments for one versus another. But as your filter media increases, 12 ounce to 14 ounce to 16 ounce, you're going to have a more dense fabric, and again, depending on the dust, your pressure drop, your pressure differential across the baghouse may increase a bit faster. But again, in most applications, you're not going to see a noticeable difference in bag life, maybe weeks, but definitely not months or years versus a 12 ounce or a 16 ounce filter bag. But again, to go back to the original question, the type of filter media as far as fabric weight does not affect how we figure air to cloth ratio.
Okay, next. Is there a way to see the MagnaHelix gauge without climbing the ladder every time?
No, you got to climb the ladder every single time. So we commonly, especially on large filters, we commonly run an airline down the leg of a filter or down the ladder or whatever makes most sense, and we can place a MagnaHelix gauge at eye level on the ground. If that's something that somebody has, that is a very easy thing to do. You can call us or call whomever you talk to and get yourself a Magnehelic gauge. Get you 50 foot of, I think ours is 1/4 inch airline. Run the line down to the Magnehelic gauge and you're in business. So no, you do not have to climb the ladder every single time to check it if you mount a secondary gauge down at ground level. And of course there are uh, automated versions or electronic versions that can send signals back to a centralized PLC. So if that's something that you want a PLC to be able to read and check on for you, you can do that as well. A little bit fancier, a little bit more cost, but that's also available.
Our next question, what do you recommend, a bag filter or a cartridge filter?
So we have standardized on bag filters, and the short reason is a lot of the folks that we work with are in the food industry. And I think among the food industry, it's pretty widely accepted that a filter bag, a smooth filter bag, is preferred over a filter cartridge. And we could have a whole conversation on that, but the reason is the deep pleats can be a place for product to get hung up, which can create mold issues, bug harbors, these types of things. And anybody in those industries know exactly what I'm talking about. Now, that's not a rule that's on the books for every food industry or every company within the food industry, but that's a pretty common theme across the industry. That's where Kice grew up. That's where we, cut our teeth over the years, so that's kind of where we've standardized. We do utilize pleated cartridges, and we can utilize pleated cartridges, and there are good times and good places to use those. A pleated cartridge is going to give you a lot more filtration area than a flat fabric filter bag, just because of all the pleats and all of the ridges and valleys. You'll get a lot more filtration media in a cartridge as opposed to a filter. So you can get a lot more filtration area out of a smaller body filter. And sometimes that becomes necessary when height restrictions come into play. Maybe would like to put, for my example earlier, a 96 bag filter in with 10-foot bags. Well, we don't have that much headspace. What if we used a 96 bag filter and we put in 4-foot pleated cartridges? Believe it or not, a 4-foot cartridge is going to give you, I would guess, 2 to 3 times more filtration area than a 10-foot long filter sock. So pluses and minuses, largely dependent upon the industry. Pluses, you can get a lot more filtration out of the same size filter body as you could with a filter bag. But again, remember that if we use filter cartridges, those need to be applied at a much lower air to cloth than we discussed today. These were based on filter bag, fabric filter bag numbers. Lower air to cloth, I would say as a general rule of thumb, below a 4-to-1 air to cloth is where you want to be on a filter cartridge, and most times below a 3-to-1, a 2.5-to-1 is where you're going to want to be with cartridges. So again, good time and a good place for both. Just be careful that you're aware of what you're working with, and if you are changing from one to the other, what effect that's going to have on the entire air system.
Okay, and this will be our last question for today. You mentioned too frequent pulse cleaning damaging bags. Is that due to the bag popping at a lower PSI, resulting in an insufficient cleaning?
No, I would say it would be the opposite. It would be the bags popping at that high PSI. It's just as if you, I don't know, I can't think of a good analogy, but if you pulse the air through this filter bag every 10 seconds, you're eventually going to wear through that filter bag, as opposed to if you pulse through that filter bag every 30 seconds, it's going to take a lot longer to wear through that filter bag, just based on the pulse, based on the force of the air against it. It's not necessarily due to the dust buildup on the outside of the filter bag. Too frequent pulsing would damage the bag by too frequent high pressure pulses punching that bag from the inside.
Okay, thank you so much. That is all that we have for our Q&A session today. If your question was not answered, we will send it forward to our presenter. I want to thank you all for your participation. I also want to thank Kice Industries and our presenter, Josh White, for a great presentation today. As a note, this webinar has been recorded and all registrants will receive a link to the recording and the presentation slides. The recording will also be available within 24 hours at grainnet.com. Thank you all again for attending, and I want to wish you all a great day.